Hello students, in this video I will solve some problems in the exercise 5.1 this regarding continuity and see this problem. Question number 1 is prove that the function f of x is equal to 5x minus 3 is continuous at x equal to 0, x equal to minus 3 and at x equal to 5. Let us prove it is continuous at three different points one by one. First, let us take the point x equal to 0 and given function is f of x equal to 5x minus 3 and at x equal to 0, what is f of x? That is f of 0. F of 0 is equal to 5 into 0 minus 3. 5 into 0 is 0. 0 minus 3 is equal to minus 3. And you find the limit of the function as x tends to 0. Limit x tends to 0 f of x. Here x tends to 0 means tending to 0 from the positive side as well as negative side of 0, that is 0 plus and 0 minus. And here the function is defined in the same way, that is 5x minus 3 in both the cases. That's why let us write limit x tending to 0 f of x. That's equal to limit x tends to 0 5x minus 3. And the limit of this is also 5 into 0 minus 3, which is equal to minus 3. And limit extending to 0 f of x is equal to f of 0. Therefore, f of x is continuous at x equal to 0. In the same way, we have to check the continuity of the function at other 2 points. Let us take the second point. And here also given function is f of x equal to 5x minus 3. And the point is at x equal to minus 3. And what is f of minus 3? F of minus 3 is 5 into minus 3 minus 3. 5 into minus 3 is minus 15 minus 3, that's equal to minus 18. And the limit extending to minus 3 f of x is equal to limit extending to minus 3 5x minus 3, that is equal to 5 into minus 3 minus 3, that's equal to minus 15 minus 3, that's equal to minus 18. And you can observe limit extending to minus 3 f of x is equal to f of minus 3. Hence f is continuous at x equal to minus 3. And let us take the third point. Given f of x is equal to 5x minus 3 at x equal to 5. And what is f of 5? F of 5 is equal to 5 into 5 minus 3. That's equal to 25 minus 3. That's equal to 22. And the limit extending to 5 f of x is equal to limit extending to 5x minus 3. That's equal to 5 into 5 minus 3. That's equal to 25 minus 3, which is also is equal to 22. Now limit extending to 5 f of x is equal to f of 5. Therefore, f is continuous at x equal to 5 also. Now let us take another question. Examine the continuity of the function f of x equal to 2x square minus 1 at x equal to 3, which is similar to the previous one. First, let us take the given function f of x equal to 2x square minus 1. And at x equal to 3, f of 3 is equal to 2 into 3 square minus 1. And 2 into 3 square is 2 into 9 minus 1. 18 minus 1, which is equal to 17. And limit extending to 3 f of x is equal to limit extending to 3, what is f of x? 2x square minus 1. Now you put x equal to 3 here, 2 into 3 square minus 1, and which is equal to 18 minus 1, and which is also equal to 17. Here limit extending to 3 f of x is equal to f of 3. Therefore, f of x is continuous at x equal to 3. See the next question. Examine the following functions for continuity. F of x is equal to x minus 5. Here we have to check the continuity at every real number. And given function is f of x equal to x minus 5. And f of x is defined at every real number c. Here it is a linear function and it is defined for every real number. And we have to check the continuity at every point c. Here the difference is instead of a particular number you have to take it as c, that's all. And what is f of c? f of c is equal to c minus 5. And you find the limit extending to c f of x is equal to limit extending to c x minus 5, and which is equal to c minus 5. Here limit extending to c f of x is equal to f of c. Therefore f of x is continuous function, and here it is continuous everywhere, and it is continuous in the set of real numbers. See the next question. Examine the following functions for continuity. F of x is equal to 1 by x minus 5, where x is not equal to 5. Here when x equal to 5, the function is not defined. That's why you have to take x not equal to 5. Now, given function is f of x is equal to 1 by x minus 5, x not equal to 5. And here you have to check the continuity of the function other than 5. Here there are two chances, that is c is either greater than 5 or less than 5. Let us take it as c not equal to 5. And when c is not equal to 5, what is f of c? F of c is 1 by c minus 5, which is defined. And limit extending to c f of x is equal to limit extending to c 1 by x minus 5, that's equal to 1 by c minus 5. And here limit of the function is equal to value of the function, that is limit extending to c f of x is equal to f of c. Therefore f of x is continuous at every point in its domain. Here the domain is r minus 5, that is set of all real number excluding 5, and the function is continuous at every point in its domain. See this question. Examine the following function for continuity. F of x equal to x square minus 25 divided by x plus 5 when x is not equal to minus 5. Here also the set of all real number excluding minus 5 is the domain of this function. And given function is f of x equal to x square minus 25 divided by x plus 5 when x is not equal to minus 5. And for every real number c not equal to minus 5, what is f of c? F of c is c square minus 25 divided by c plus 5, which is equal to c square minus 25 can be written like this, c plus 5 into c minus 5 divided by c plus 5. C plus 5 gets cancelled, and that's equal to c minus 5. And what is limit extending to c f of x? Limit extending to c f of x equal to limit extending to c x square minus 25 divided by x plus 5. That's equal to limit extending to c x plus 5 into x minus 5 divided by x plus 5. X plus 5 gets cancelled. That's equal to c minus 5. And here limit extending to c f of x is equal to f of c, and therefore f of x is continuous at every point in the domain of f, and hence f of x is a continuous function. Now you see this question. Examine the following functions for continuity. F of x equal to mod x minus 5, and given function is f of x equal to mod x minus 5. And what is the meaning of mod x minus 5? You know the definition of mod x. Mod x is equal to x when x is greater than 0, and minus x when x is less than or equal to 0. And you can write mod x minus 5 as x minus 5 when x minus 5 is greater than 0, that is x is greater than 5, and 5 minus x when x is less than or equal to 5. This is the definition of mod x minus 5. Now to verify the continuity of the function, let us take the points in three different regions, that is c be a real number. It may be either equal to 5, or it may be greater than 5, or it may be less than 5. As the function is defined in a different way, we have to take the value of c also in the different interval. And first let us check the continuity of the function at c is equal to 5. And the given function is f of x equal to x minus 5 when x greater than 5, and 5 minus x when x is less than or equal to 5. And when c is equal to 5, what is f of c? That is f of 5 is equal to 5 minus 5 is equal to 0. And limit extending to 5 f of x is equal to limit extending to 5 mod x minus 5, and that is also equal to 0. Here limit extending to 5 f of x is equal to f of 5, and hence f of x is continuous at x equal to 5. And then let us take the real number c, which is greater than 5. When c is greater than 5, what happens, you just see here. When c is greater than 5, what is f of c? F of c is c minus 5. When x is greater than 5, what is f of x? X minus 5. And f of c is equal to c minus 5. And the limit extending to c f of x is equal to limit extending to c mod x minus 5, that's equal to c minus 5. And limit extending to c f of x is equal to f of c. Therefore, f of x is continuous at x equal to c. Now let us take c is less than 5. When c is less than 5, f of c is equal to, see here, when x is less than 5, what is f of x? 5 minus x. And f of c is equal to 5 minus c. And limit extending to c f of x is equal to limit extending to c mod x minus 5, and which is equal to 5 minus c. That is, when x is less than 5, what is mod x minus 5? That's equal to 5 minus x. And here it is 5 minus c. And you can observe that limit extending to c f of x is equal to f of c, and therefore f of x is continuous at x equal to c for all real number less than 5. Thus we will have f of x is a continuous function. Now we see this question. Prove that the function f of x is equal to x to the power n is continuous at x equal to n, where n is a positive integer. What is the given function? F of x equal to x to the power n, and you have to check the continuity at x equal to n. And first you have to find f of n. And what is f of n? N to the power n. And also you find the limit extending to n f of x. Limit extending to n f of x is equal to limit extending to n x to the power n, that's equal to n to the power n. And limit extending to n f of x is equal to f of n. See here, limit extending to n f of x is also n to the power n, f of n is also n to the power n, and both of them are equal. Therefore f of x is continuous at x equal to n. And with this much I'll conclude this video, and in the next session let us continue with the other type of questions on the continuity. Thank you.